Welcome back to section 4.4. We're going to be talking about reference angles today. And a reference angle, we label it as theta prime, that has a little tick mark next to it. That's the angle that's going to get us back to that x-axis, the quickest way. Now, one thing with reference angles, they're always going to be positive. And they're always going to be acute. They're always going to be acute positive angles. So if you take a look, and we're in quadrant 2, we're trying to find the angle to get us back to the x-axis the quickest way. So the reference angle would be this angle right here, theta prime. That's going to get us back to 180 or back to pi if we're thinking in radians. When we're in quadrant 3, our reference angle is going to go this way. That's theta prime. It's the quickest way to get back to the x-axis. It's that acute angle. They're always going to be positive. Keep that in mind. And in quadrant 4, the quickest way to get back is going that way. That's our theta prime right there, that small acute angle. That's going to give us an angle that's equivalent to that in the first quadrant. That's really what our goal is with a reference angle. Find the reference angle theta prime. So if we're at 300, I'm going to draw a sketch. 300 degrees. That's going to take us counterclockwise and into that quadrant 4. That's 300 degrees. So what we could do is that theta prime, our reference angle, is 360 minus 300. So our reference angle theta prime is 60 degrees. For number 7, theta is 2.3, and that's in radians. Now, pi radians, pi is 3.14. That's going to get us to that axis. So 2.3, that's going to be in quadrant 2. So to find theta prime, we're going to do pi minus 2.3. Use the pi button on your calculator and subtract the 2.3. You're going to find out the reference angle theta prime is about 0.8416. And that's in radians. And now looking at problem number 8. I always like to draw a little sketch. It just helps me visualize. Negative 135. Now it's negative. We're going clockwise. Now it's going to get us past that axis, but it's going to bring us into quadrant 3. There's my negative 135 degrees. I need to find my reference angle, and that's going to bring me back here. So what I can do is I can do (180) minus 135. I know it's going to be positive anyway. I'm just going to take the bigger number and subtract the smaller number, and that's going to give me a 45 degrees. So there's my theta prime. So you want to think about it a little bit. There's other ways to do it. I think that's the easiest way. Theta prime is 45 degrees. It's going to be 45 degrees to get us back to the x-axis. Once again, reference angles are always positive, so it doesn't really matter which way the reference angle is going. It's always a positive angle. Let's do some more. Theta prime for a 213 degree angle. I like a sketch to visualize. 213, that's greater than 180. So it's going to bring me down to quadrant 3. Now my reference angle, once again, is the quickest way to get back to the x-axis. So to find theta prime, I can do 213 minus 180. So theta prime is going to be 33 degrees. Always a positive number. Even if you switch them around, just change it to a positive and you're good. Theta equals 1.7. Now 1.7, to get us to pi, it's 3.14. Half of that, we're going to be a little bit past it. So there's our angle. So theta prime is going to be right here to get us back to pi. So theta prime, pi minus 1.7. Use your calculators for the pi button, and you're going to get about 1.4416 for theta prime, for your reference angle. When theta is negative 36, remember that negative angle, we're going clockwise. We're in that fourth quadrant. So theta prime is going to bring me back to the x-axis as quick as possible. So really all we're going to be doing is just going backwards, going another 36 degrees. So theta prime is 36 degrees. Really not a whole lot of work there because we're working with an acute angle already. We just had to make it a positive, and there we go. All right, on the next page. You can kind of read through all this. It's really just talking about how we can use reference angles to find out what the value would be. So when we think about it, think about your unit circle. For our pi over 3, for our pi over 3, we have, pi over 6 first. My pi over 6, I'm going to have my root 3 over 2 and the 1/2. Then I got my pi over 4 and my pi over 3. That's going to be 1/2 root 3 over 2. Just remember one, you just flip them to get the other one. And the pi over 4s are root 2 over 2, root 2 over 2. And the tangents for those, it's going to be for pi over 6, root 3 over 3. Pi over 4, it's going to be 1. And for pi over 3, it's going to be root 3. Keep in mind, the sine of theta is your y, and the cosine of theta is your x. Also, the unit circle, 0, 1, 1, 0, negative 1, 0, 0, negative 1. Quadrant 1, they're positives. Quadrant 2, negative, positive. Quadrant 3, negative, negative. And quadrant 4, positive, negative. So for the sine of 0, sine of 0, 0, the y-coordinate is 0. The sine of 30, which is our pi over 6, that's going to be 1/2. Sine of 45, the y-coordinate, root 2 over 2. Of 60, our pi over 3, that's going to be root 3 over 2. And for 90, we're at pi over 2. That's going to be 1. And our cosines of 0, it's at x-coordinate, it's 1. For 30, it's root 3 over 2. 45, root 2 over 2. And 60, it's the 1/2. And then for 90, it's going to be 0. You can fill in those values pretty quickly. Now, we can kind of fill this in. Remember, pi radians. So 0 would be 0 degrees 0 pi radians. Pi over 30 is pi over 6. 45 is pi over 4. 60 is pi over 3. 90 is pi over 2. 180 is pi. 270 is 3 pi over 2. So you can use this and kind of fill in the values pretty quickly from above. For 0, we already have for 0, 30, 60, and 90 for sine and cosine. So I'm just going to copy them down. 0, 1, 1/2 root 3 over 2, root 2 over 2, root 2 over 2, root 3 over 2, and 1/2. And then 1 and 0. We already have all those. Now to find the tangents, I'm just using this right here that I have labeled. When it's pi over 6, it's going to be root 3 over 3. Pi over 4 is 1. And then pi over 3, it's root 3. So for 0, it's going to be 1. When we're at 30, at that pi over 6, it's that root 3 over 3. When I'm at pi over 4, it's 1. When I'm at pi over 3, it's root 3. Now for the 90s, it's just 1 divided by 0, which is undefined. When we're at 180, we're at negative 1, 0. So for the sine, 0. For the cosine, negative 1. And for the tangent, 0. 3 pi over 2, we're at 0, negative 1. My sine is the y, negative 1. My cosine is 0. And my tangent is undefined. And that's just a quick way to fill it out using our known information. All right, let's do some more that have to do with talking about what quadrant we're in and so forth. So we're going to evaluate knowing that cosine is 4 pi over 3. The cosine is 4 pi over 3. Now, if cosine is 4 pi over 3, whenever I see that over 3, I know it's going to be 1/2 root 3 over 2, and my tangent's going to be root 3. I'm just going to keep it there for reference. Now, 4 pi over 3, that's going to be in quadrant number 3. When I'm in quadrant 3, both of my values are negative. Tangent's still going to stay positive. So to evaluate cosine of 4 pi over 3, what that is, the cosine of 4 pi over 3, that is going to be the x-coordinate. It's a negative 1/2. What I just did there was I used reference angles. The reference angle was right in the beginning. I knew that my pi over 3s, it's going to be the same as my pi over 3s. And I knew quadrant 3, so I just threw my values in there. That's all we did. Now, the tangent of negative 210. Now, I'm used to working with this in radians, although I can use this negative 210 to help me out a little bit. Going backwards, that's going to bring me all the way to quadrant 2. Now, 210 degrees. We multiply that by pi over 180. They're both divisible by 30. That gives me a 6, and that gives me a 7. So I get 7 pi over 6, a negative 7 pi over 6, because I'm this way. Now, all I need to know is that I'm in quadrant 2, and I have a pi over 6. And every time I have a pi over 6, I'm at root 3 over 2, 1/2. And my tangent would be root 3 over 3. Now, since I'm in quadrant 2, my x-coordinate is negative, my y-coordinate is positive, and my tangent is going to be negative as well. So I'm going to have the tangent of negative 210 degrees is equal to the tangent of negative 7 pi over 6, which is equal to negative root 3 over 3. There's my answer. The cosecant of 11 pi over 4. All right, now, whenever I see an over 4, I know I'm going to have a root 2 over 2 and a root 2 over 2. Now, 11 pi over 4, I'm going to visualize this. 11 pi over 4, that's pretty big. So if I go 4 pi over 4, that's one circle, and then 8 pi over 4 is another circle. So 11 pi over 4 is the same as 8 pi over 4 plus, we'd have 3 pi over 4 remaining. That 8 pi over 4 is 2 pi. That's one full circle. I don't care about that. That's all that's saying is I'm going this. And then I have another 3 pi over 4, bringing us into quadrant 2. I'm in quadrant 2. I know my signs are negative for x and a positive for y. Now, knowing that cosecant is the reciprocal of sine. The sine of 11 pi over 4 is going to be root 2 over 2. So the cosecant of 11 pi over 4 is the reciprocal. That's going to be 2 over root 2, which when we rationalize it, we get root 2 over 2, we get 2 root 2 over 2, which is the square root of 2. So the cosecant of 11 pi over 4 is root 2. And here we have it. So let's do a few more. Number 15. Let theta be an angle in quadrant 2 such that the sine of theta is 1/3. Find the following using the trig identities. So our trig identities, one deals with cosine, the Pythagorean identity, sine squared theta plus cosine squared theta equals 1. I don't even need to draw a triangle. I do know I'm in quadrant 2, so that is important. So in quadrant 2, sine is positive, but cosine is negative, and tangent is also a negative. So keep that in mind. So what we have here is we can do 1/3 squared plus cosine squared theta equals 1. 1/9 plus cosine squared theta equals 1. Subtract 1/9 from both sides. So we get is cosine squared theta equals 1 is the same as 9 over 9 minus 1/9. And what you're going to get is that the cosine squared theta equals 8/9. Take the square root of both sides. Cosine of theta equals the square root of 8 over the square root of 9, which is going to be 2 root 2 over 3. And because it's in quadrant 2, it's a negative 2 root 2 over 3. Excuse me, something happened. Sorry about that. So it's going to be negative 2 root 2 over 3. Now, I think that's actually kind of messy. Probably the easiest way to do it. Theta, we know we're in quadrant 2. Here's my triangle in quadrant 2. Here's theta. Sine is opposite over hypotenuse. It's 1 over 3. They're both positive. Now we can find the missing side of that triangle. A squared plus b squared equals c squared. So 1 squared plus b squared equals 3 squared. 1 plus b squared equals 9. B squared equals 8. So b equals 2 root 2. Now, because we're in quadrant 2, it's going to be a negative, and you can actually just see cosine is the adjacent over the hypotenuse. So what is going to be cosine of theta, negative 2 root 2 over 3, and I think that was actually way quicker was drawing the triangle. And then you could do tangent. You could either do the sine of theta over the cosine of theta, or if you drew the triangle, you could just look, all right, my tangent of theta is going to be the opposite over adjacent. It's going to be 1 over 2, negative 2 root 2. So the tangent of theta is going to equal, so rationalize it. So you get root 2 over negative 2 times 2. So it's root 2 over negative 4. Or negative root 2 over 4. That's the tangent of theta. You could do it either way. You could use the identities or draw the triangle. Honestly, most of the time, I'm going to draw the triangle. Let's do another one where we're going to draw the triangle. The sine of theta is negative 5 pi over 13. And theta is between pi and 3 pi over 2. That's telling us we're in quadrant 3. Sine opposite over hypotenuse. So the opposite is 5, hypotenuse is 13. Now, we're in quadrant 3, so my y-coordinate's also negative. Pythagorean theorem to find the missing side. So the missing side, so 5 squared, negative 5 squared plus b squared equals 13 squared. 25 plus b squared equals 169. B squared equals 144. B equals 12. Once again, 12, but we're in quadrant 3, so they're both negative. So now to find the cosine of theta, cosine, adjacent over hypotenuse, it's going to be negative 12 over 13. Done. Tangent of theta, opposite over adjacent, negative 5 over negative 12. It's a positive 5/12. And the secant of theta is the reciprocal of the cosine. It's going to be 13 over negative 12 or negative 13/12. And there we have it. Now we're just going to use a calculator to verify to figure these out. The first one, you need to be in degrees. Since your calculator doesn't have a cotangent button, it's 1 over the tangent of 410. When you do that, you're going to get about 0.8391. The next two are in radians. So you're going to find the sine of negative 7 in radians. You're going to get negative 0.6570. The secant, you don't have a secant button, so it's 1 over the cosine of pi over 9. So make sure in radians, you're going to get it 1.0642. And now to evaluate the tangent of 4.812, find theta in radians. So what we're going to do is theta is between 0 and 2 pi. It's going to bring us back to that angle that's less than 1 full circle. So to undo tangent, you want to use the inverse tangent. Tangent inverse of tangent theta equals the tangent inverse of 4.812. Tangent and tangent inverse cancel out, so theta equals, and when you type this in your calculator, make sure you're in radians, 1.3659 radians. That would be the measure of the angle that has that value for the tangent. Okay, thank you for your time. I will see you in the next section.